Section 5.3, problem number 21, we're going to verify this identity. Sine of 3 theta equals 3 sine theta minus 4 sine cubed theta. So I'm going to start with the left-hand side, even though the right-hand side, so I'm looking for the more complicated side. The left side is, while it's smaller and looks simpler, the fact that there's a 3 theta in there that I have to break apart into just sine of thetas makes me think this is more complicated, because I cannot get to the sine theta without breaking this into something more complicated. So I'm going to start by breaking down sine of 3 theta into 2 theta plus theta. Okay, and then I just have the sign of a sum, so I can use our sum identity, which is sine of 2 theta times cosine of theta plus cosine of 2 theta sine of theta. Now I have a sine of 2 theta and a cosine of 2 theta that I can break down even more. So this is, I'm still working on my left side, so I'm going to write that down. So I'm working on my left side of this identity and trying to make it look like the right side. So I'm just going to keep breaking this down and break it down as far as I can. So sine of 2 theta is using that double angle identity, 2 sine alpha theta times cosine of alpha. I'm sorry, theta. Okay, so that's just this part that I'm rewriting like that. And then that is times the cosine that I'm not going to change at all, plus, and then I have this piece that I'm going to use a double angle identity for cosine. But this time I have some choices here. I have 3 different choices. And looking at the right side, my goal is to get this to have like this. So I want to get rid of all those cosines and make them turn into sines. So there's only one identity, a double angle identity for cosine, that has no cosines and just sine. So let me use that one, which is 1 minus 2 sine squared theta. And that multiplied by sine of theta. Okay, so I'm going to keep going. Now that this on the right breaks, I'm just going to divide this out, and I get, just distributing that, I get sine theta minus 2 sine cubed theta, just multiplying that sine theta into the parentheses. And on the left, simplifying this, I can combine those guys. So I get 2 sine theta cosine squared theta. Okay, now remember the idea here is looking at that right side that's highlighted in yellow. I want to get rid of all my cosines and express everything in terms of sine. So I'm going to now replace this guy with the equivalent signs. So cosine squared plus sine squared equals 1. So I can express cosine squared as 1 minus sine squared. And multiply that instead of the cosine squared. I'm going to leave the stuff on the right the same. Not doing anything with that right now. And then on the orange part, I just want to distribute this to get rid of my parentheses. So I'm going to distribute this times 1 and then times sine squared. So I get 2 sine theta, and then to do times minus sine squared, I get 2 sine cubed, which is looking pretty good, because that means I'm starting to get some cubes in here, and I have the terms that I have on the right. Now I think it's just a matter of combining like terms. So let's find out. Let's see. let's highlight our like terms. So we have our sine theta with a exponent of 1. The base is sine, the exponent is 1. I can combine those. And that gives me 2 sine theta plus 1 sine theta equals 3 sine theta. And then combining the other like terms, that's the negative 2 sine cubed, and another negative 2 sine cubed gives me minus 4 sine cubed. And this looks like this guy, which is the right side. So this equals the right side. So now I have left side equals right side. So my identity is proved.